Angle of depression. The learning target for this video, I can solve word problems involving angle of depression. Guide questions. We have what is an angle of depression? What are some examples of angle of depressions in real life? And lastly, what is the key difference between angle of depression and angle of elevation? First, we have the definition for angle of depression. It's the angle between the horizontal axis and the line of sight to the object when the observer looks downward. So again, our angle of depression is this one. Okay, problem number 1. So based in this problem, our illustration will be this one. Now, I would like you to be aware that in solving word problems involving angle of depression, we do have different ways for us to solve for these problems. So first, I would like you to consider our first problem to explain the two ways to answer angle of depression problems. So here, as you can see, I would like to emphasize first the details given in the problem. Our angle of depression is 60 degrees and the lamp post is 10 meters, and then we are supposed to find out the light beam, which is for now we represent as x. So here, applying the concept of complementary angles, guys, as you can see, through the lamp post and then the horizontal line, so we can have a perpendicular line. Perpendicular line, that means it forms 90-degree angle. And now as you can see, our angle of depression is 60 degrees, and we all know if that is a perpendicular line or complementary angles, that means the sum of the measures of the two angles is equal to 90 degrees. Now, if our angle of elevation here is considered 60 degrees, and as per our illustration, we can see that we do have here the light beam. That means it forms another angle, and if we do have here 60 degree for the angle of depression, therefore the remaining measure of the given angle is 30 degrees. The 60 degrees plus 30 degrees is equal to 90 degrees. They are complementary angles. Therefore, we can now use the idea or the detail, which is 30 degrees, to solve the problem, because it is somehow easier for us to determine the parts of the triangles, as since 10 meters lamp post and the hypotenuse is more related to 30-degree angle in relation to our illustration. Now, let's just form or put a horizontal line here on the ground. So, yan. So because of that, we're able to form a triangle, and now we can easily identify the relationship of this 30-degree angle to the rest of the details given. Now, if we do have here a 30-degree angle and finding out the relationship of the rest of the details mentioned, so as you can see, the 10 meters here is considered the adjacent side of the given triangle, and the x here is considered the hypotenuse side of the given triangle. Now, you recall what trigonometric ratio pertains to the use of adjacent side and hypotenuse side. So, that is cosine ratio. Now, that means you may already start the solution by writing the formula cosine 30 degrees equals adjacent divided by hypotenuse. Set. But aside from that, guys, we can also use another way to solve this problem. So it's an application of parallel lines cut by a transversal line, or angle pairs also. So that's the idea of alternate interior angles. We all know that if a parallel line cut by a transversal line, then we can have pairs of angles. Now we can have, since the light beam here is considered as the transversal, therefore we can say that it forms an alternate interior angle. And as you can see here in our illustration, if our angle of depression is 60 degrees, and therefore the alternate interior angle for the 60-degree angle is this one, and thus it measures 60 degrees as well. So now, if we're going to focus or consider with this data and identifying the relationship of the rest of the details, we can say that 10 meters is considered the opposite side of the 60 degree, and x is considered the hypotenuse as well. So, recalling the formulas for the 6 trigonometric ratios, which one pertains to the use of opposite and the hypotenuse? So, and that is sine ratio or sine function. So therefore, you can now start the solution by writing the formula sine 60 degrees equals opposite divided by hypotenuse. Now, for you to be able to understand more on how to do the computation, let us start with this one, cosine 30 degrees. So again, it's the application of complementary angles concept. So cosine 30 degrees equals adjacent divided by hypotenuse. Substituting in the formula, we all know that our adjacent side there in the illustration is 10 and our hypotenuse is x for now. So cross multiplying will have x times cosine 30 degrees equals 10, and then since we are tasked to find out the value of x, so we need to isolate x in the given equation. So we need to divide both sides by cosine 30 degrees to isolate the x at the left side. So now, cancelling cosine 30 degrees both in the numerator and denominator at the left side of the equation, we'll have now x equals 10 over cosine 30 degrees. Maybe others will be using this one. They will apply the idea of special triangles that we all know. Cosine 30 degrees equals square root of 3 over 2, and then they would have 10 over square root of 3 over 2, and then they will rationalize until such time they end up with 20 square root of 3 over 3, and they will encode that in the calculator, and they will get x is approximately equal to 11.547. But actually, you can directly input in your calculator the 10 divided by cosine 30 degrees, and you will also get 11.547. Lastly, you will write your final answer in sentence form. Thus, the length of the beam of the post is approximately 11.55 meters. Now, this is our computation based on the application of the complementary angles. What if we're going to use the idea of the application of alternate interior angles? Let's see if we will have the same answer as this, 11.547. So here, we are supposed to use sine 60 degrees. Our formula for sine is opposite divided by hypotenuse. Substituting in the formula, we'll have sine 60 degrees equals 10 over x. Now, cross multiplying, we'll have sine 60 degrees times x equals 10. Then, we need to isolate the x there. So we will divide both sides by sine 60 degrees. So we will cancel out sine 60 degrees both in numerator and denominator at the left side of the equation. Then we will end up with x equals 10 over sine 60 degrees. So you may now input that in your calculator and you will already get your answer. But for others, maybe they would get first what is sine 60 degrees in their calculator and they will end up with 0.866025403, or maybe others will be looking at the radical equivalent of sine 60 degrees. But I would suggest that you make use of your calculators because you do have your calculators with you already. So you just input 10 divided by sine 60 degrees and the calculator will give you this answer, 11.547. Same answer with what we got from cosine 30 degrees a while ago. That's it. Thus the length of the beam of the post is approximately 11.55 meters. Next, we have our problem number 2. So based here in this problem, our illustration will be this one. So for this, I will be using the second way of solving angle of depression problem. So the application of alternate interior angles. So here, as you can see, since the angle of depression is 12 degrees, therefore this angle, the alternate interior angle, will be considered as 12 degrees as well. And now, to find out the trigonometric function that we are supposed to use for our computation, just identify first what are the details given. So here we have 60 meters. This is considered the opposite side, and we are supposed to find out the adjacent side, which is represented as x. So therefore we are supposed to use tangent function or tangent ratio. Now let's start our solution with tangent 12 degrees equals opposite divided by adjacent. Now substituting in the formula, we'll have 60 divided by x, and cross multiplying, so we'll have tangent 12 degrees times x equals 60. So here I'll just directly go on with isolating the x by simply dividing both sides by tangent 12 degrees. So we will cancel out, so we'll end up with x equals 60 divided by tangent 12 degrees. And in here, we can now input in our calculator and we will end up with our final answer, which is 282.2778. Okay, so we need to write it in sentence form. Okay, problem number 3. So according to our problem, so our illustration will be this one. So now, so as you can see, our angle of depression is 32 degrees, and still I'll be using the application of alternate interior angles. So if this is 32 degrees, therefore the alternate interior angle will be also 32 degrees. And now, identifying the trigonometric ratio I am supposed to use for my solution or computation. So let me check first the given data. We have here this is the opposite side of 32 degrees, and we have here what is the distance of the ship from the foot of the lighthouse. Then we have here, so that means that this is supposed to be our x, and if we're going to look at the relationship of this side to 32 degrees, this is considered the adjacent side of the given triangle. So therefore, we are supposed to use tangent ratio once again. So tangent 32 degrees is equal to opposite divided by adjacent. Substituting in the formula, we'll have 127 over x. Then cross multiplying, we'll have x times tangent 32 degrees equals 127. And isolating the x, we'll have divide both sides by tangent 32 degrees and then cancel out necessary details. So we'll end up with x equals 127 divided by tangent 32 degrees. In this case, we can now input in our calculator. So we'll end up with 203.242485.2. And in sentence form, therefore, the distance of the ship from the foot of the tower is 203.24 meters. Next problem. So, based here in our problem, so we are supposed to find out the angle of depression. It is not given yet. So, again, I'll be applying the idea of alternate interior angles. So if this is theta, so that means the alternate interior angle will be theta as well. So we are supposed to find out the angle of depression. So as you can see, based on the details given, 45 degrees is considered the opposite side and 53 degrees is considered the adjacent side. Therefore, we are supposed to use again tangent function or tangent ratio. So now we are going to use the formula for tangent theta, which is opposite divided by adjacent. Substituting in the formula, we have 45 divided by 53, and we can now input in the calculator and get the equivalent value of 45 over 53 in decimal number, and we'll get this. And then to isolate theta there, we are supposed to divide both sides by tan. So we'll end up with, canceling the tan there, we'll end up theta equals 0.849556 and 3 divided by tan. If you're going to input this in your calculator, we'll end up with syntax error. So we need to rewrite this expression into its original form, particularly the tan in the denominator. So that means it is the inverse tangent. Okay, inverse function, that should be theta equals tangent raised to -1 times the numerator. And we'll end up with theta is approximately equal to 40.33314, but we must end up with sentence form. Therefore, the angle of depression from the office window of the worker to the jolly jeep is 40 degrees. According to our instruction, the angle of depression must be to nearest whole number. Okay, next, based on our problem, so we have here the angle of depression is 20 degrees. Now, following the concept of alternate interior angles, that means this is also 20 degrees. So now, identifying the parts of the triangles based on the given data. So x here is our opposite and 2 meters is our adjacent. Therefore, we're supposed to use tangent ratio or tangent function again. So here in our solution, we have tangent 20 degrees equals opposite divided by adjacent. Then, substituting in the formula, we have x over 2. Then, cross multiplying, will end up with x equals 2 times tangent 20 degrees. Now, so 2 times tangent 20 degrees. You may directly input that in your calculator, but for some, maybe they will just get first the equivalent of tangent 20 degrees, and then he or she ended up with 0.36, 39, 70, 234. But again, you may directly multiply it with 2. So you'll end up with x is approximately equal to 0.7279. So in sentence form, you must have this. Therefore, the distance of the camera from the ground is 0.73 meters. So that's it for this topic. Thank you so much for watching. I hope you learned about word problems involving angle of depression. So do not forget to subscribe now in our channel so that you will be updated of our playback videos. Thank you so much for watching.